Hi everyone, Ethan from Microchip Technology here. In today's video, we are unboxing two of Microchip's latest low-cost development boards designed to make 32-bit embedded design simple and straightforward. We've got the PIC32CM GV00 and the PIC32CM JH00 Curiosity Nano kits, both built around the Arm Cortex M0 Plus core, so you can get an efficient, low-power way to bring your next embedded project to life. So, before we take a look at the development boards, let's take a closer look at what makes each of these boards unique and why they might be the perfect fit for your next embedded project. The PIC32CM GV00 and PIC32CM JH00 microcontrollers are designed for energy-efficient, always-on applications that need long battery life and reliable performance. They share key features that simplify embedded design, including a peripheral touch controller, which is supported by Microchip's touch libraries, which makes it simple to implement touch into your design. This makes it easy to create smooth, responsive user interfaces without the need for external components or complex firmware. So, on top of the peripheral touch controller, both devices feature a 12-bit analog-to-digital converter for precise signal processing, SERCOM for flexible communication, and a PDID, which is a one-time programmable option that provides added security to your embedded design. The GV00 family goes up to 32 kilobytes of flash, while the JH00 family offers up to 64 kilobytes, giving you more headroom for more advanced applications if needed. So, now that we talked about the similarities between the two, let's go ahead and talk about the differences between the two devices. The PIC32CM GV00 is a 3-volt device built for compact, power-sensitive system. It includes a 10-bit digital-to-analog converter, and when combined with its 12-bit ADC and peripheral touch controller, this enables smooth, responsive interfaces without the need for additional components. On the other hand, the PIC32CM JH00 operates at 5 volts, offering stronger noise immunity for industrial and electrical noisy environments. It features 16-bit and 24-bit timers for motor control, signal generation, and precise timing tasks. Both families support functional safety and meet AEC Q100 standards, making them suitable for automotive and safety-critical applications. With the rich set of integrated peripherals, they reduce external component count, lowering BOM costs, saving board space, and improving system reliability. So, now that we've talked about the key features and differences between the two devices, let's go ahead and open up the evaluation kit box and take a closer look at the development boards themselves. At the heart of each board is the microcontroller itself, either the GV00 or JH00. Each Curiosity Nano also includes built-in components to help you prototype quickly without the need for additional breakout hardware. You'll find an onboard debugger, a user LED, a capacitive touch button, and a push button for user input. The staggered headers give you easy access to key I/O pins, making it simple to connect the board to a breadboard or plug into a Curiosity Nano baseboard if needed. The board is powered over a USB-C, so you can connect and get started right away. And that's all there is to it, a simple yet powerful board that gives you everything you need to bring your ideas to life. So, now that we've unboxed the Curiosity Nano development board, let's take a quick look at how easy it is to get your first application up and running by programming the PIC32CM GV00. I also want to note that this process is the same for programming the PIC32CM JH00 as well. So with that said, let's go ahead and get started. So, to start programming the PIC32CM GV00, let's go ahead and head over to the Curiosity Nano landing page, which you'll find linked in the description below. You'll also find a link to the PIC32CM JH00 Curiosity Nano page as well if you want to follow along and program that device. Each page includes information about the onboard features of the Curiosity Nano board, helpful documentation to get you started, and a link to purchase the kit. So let's go ahead and scroll down to the software section on this page and look for the Getting Started application. This is a pre-built project created for your convenience to test out the Curiosity Nano board and see how everything works right out of the box. This Getting Started example for the PIC32CM GV00 toggles the onboard LED at different intervals and sends the current timing value to the serial terminal each time the switch is pressed. So let's go ahead and click the download link to grab the project. Once the download is complete, let's extract the contents so we can open up this project in MPLAB IDE. MPLAB IDE is Microchip's integrated development environment. It's where you can build, program, and debug your application using tools like Harmony v3. For more information on MPLAB IDE, check out the links in the description below. I also want to mention that the project folder also includes a README file which goes into more detail about how the Getting Started code example works and which peripherals are used. So now that we've extracted the project files, let's open it up in MPLAB X IDE. To do that, go to File, Open Project, and navigate to the folder that we just extracted. Inside the firmware folder, you'll find a file with a .x extension. This is the MPLAB X project file. Let's go ahead and open this. Once it's open, right-click the project in the Projects tab and set it as the main project. Then, click the Make and Program Device button at the top to flash the board. When prompted, make sure to select the Curiosity Nano you are using as a tool to be programmed. In our case, we are using the PIC32CM GV00, and after programming is complete, you will see a confirmation message in the output window. With the board now programmed, let's take a look at the hardware in action. As you can see on camera, the LED blink rate changes with each press, cycling through 500 milliseconds, 1, 2, and 4 seconds before looping back. I'm also using MPLAB Data Visualizer as a serial terminal to display the LED toggling rate in real time. So that wraps up today's video. For more information on the PIC32CM GV00 and JH00 devices we just covered, check out the links in the description below. You'll also find a link to purchase the evaluation kits to start testing them out yourself. As always, thanks for watching, and if you found this helpful, be sure to like, comment, and subscribe for more.